Cut on set.
Welcome to Perspectives on Healthy Living. I'm Gabrielle Antolovich, your host with Voices United in collaboration with the Pathway Society. We are with Lisa Frederiksen, who is an author and an extraordinary presenter, and with BreakingTheCycles.com, an amazing website.
Thank you. Thank you. It's so good to be here again with you.
I know. And we're going to be talking about the teenage brain, but you know, the brain has a long cycle of evolution. And when it comes to addiction, we used to think that it was, you know, people's willpower. But now we know it's about the brain chemistry. So tell me about that.
That's true. There's some amazing research, and it's just been in the last 10 to 15 years due to advances in imaging technologies that allow scientists to study the live human brain in action over time, under the influence, with mental illness, after treatment. It's just amazing what they can now see. And so what they now understand is that it is a chronic, often relapsing, but definitely treatable brain disease.
Huh.
Yes, and it's that brain disease piece of it that explains why a person's behaviors change, why that particular individual cannot drink any amount or substance any amount and not fall into the addiction-related brain maps. It's quite fascinating.
So even though this information's been around for 10, 15 years, it hasn't really reached most of the people's understanding. So people are still thinking, you know, if you're using a drug, why don't you stop?
Yeah, it's so true, and I think it's a lot to do with the shame still that surrounds it and the belief that it is a willpower issue. And so there's roughly 23.2 million Americans who struggle with addiction, but only 10% get treatment. Compare that to about 12.5 million living with all cancers and 1.1 million with HIV. So here we have, say, cancer, roughly half of the number that have addiction. And yet, most of us know somebody who has cancer. We talk to them. If somebody has cancer, we bring them potlucks, gifts, watch the children, come pouring forth with, you know, just empathy and sympathy and support. But addiction, we still treat as, oh my gosh, that's a bad person. And so we shun it, and so nobody wants to talk about it if they have it. The family doesn't want to talk about it, and so we just continue this.
And we desert people.
We do, yeah. We see them as their disease versus as a person with this disease. So when somebody has cancer, we see them as the person who has cancer instead of, oh, you're canceric. And so hopefully with this new research, so that people can understand how it is that some people who drink too much never cross the line, and others who do cross the line, or use drugs experimentally and then don't become addicts. There's a whole progression here. And so that's why talking about the teen brain is particularly helpful, because it often starts in adolescence.
Right.
Typically, for the most part, most of them, yes.
So can you describe a bit about, you have a slide about the brain.
The neural networks?
Yeah. Can you describe what that's about?
Sure. This is sort of the key to how the brain communicates. So cells in the brain, neurons, communicate with one another, and then they communicate to other neurons throughout the body through the nervous system. And these talking, if you will, is what's called a neural network. And so it takes a cue, which triggers one cell. You'll see in that image kind of one blob, shoots an electrical signal down the outgoing extension, and then it'll get picked up on the incoming extension and take that electrical signal onto the next cell.
A bit like a telephone call.
Yes, or like a string of Christmas lights.
Oh,
yeah,
right.
with the bulbs being the cells and then the wiring coming in and out being these extensions. But the key part is that it's an electrical signal. So something has to take that signal and convert it to cross what they call a synapse, which is a gap between these two extensions. And that something is a neurotransmitter, and that something is a chemical. So it takes the electrical signal, converts it into a chemical that can float that gap, converts it back, binds into receptors, and carries the message then back into an electrical onto the next cell. I don't think I explained that very clearly.
Oh, no, it's complex.
Yeah, and so the idea is that drugs and alcohol all get through to the brain, through the bloodstream, whether we smoke it, ingest it, drink it, and it gets into the brain, and it interrupts that communication system, and that is what changes a person's behavior. And yet we'll excuse it, oh, well, they didn't eat, or they had a bad day, or it was the kids yelling, or it's nothing else than the chemical changes that occur when somebody drinks more than the body and brain can process or takes drugs not as prescribed. So.
Wow.
Yeah.
That's interesting. And it also seems like it's a delicate process.
It is.
It's not like, you know, throwing gasoline, you know, it's like throwing gasoline into the fire.
So anything that happens in the brain, whether that be poor nutrition, not enough sleep, not enough exercise, certainly drugs and alcohol, anything that changes the way that the cells, the health of the cells, the incoming and outgoing, the neurotransmitters, changes the way the brain behaves and works. And so that's why drugs and alcohol work on parts of the brain, which is what suppresses the way these networks come together, not come together, but, and let me just back up here a minute. These wires, if you will, a lot of them are instinctual. We're born with the ability, because the brain controls everything we think, feel, say, and do. So we're born with the ability to breathe or to eat. But a lot are by repetitive activation. And so there's an expression that's neurons that fire together, wire together, and then they form brain maps around everything we think, feel, say, and do. And the next slide, which shows a 3-brain-brain complex, this slide helps us understand where these networks are wiring. This is typically the region of the brain where these activities are occurring. So you have the base, that's the cerebellum, and they call that the motor skills. And then we have the limbic.
When you say motor skills, what's that?
Like breathing and heartbeat and walking, it's that effort.
Oh, right.
Yeah.
And you have to learn that too when you're a baby.
Right, exactly, exactly. And then the limbic part of the brain is a reactionary part, and that's where we have fight or flight, pleasure, reward, pain, and emotion. And when it comes to addiction, that's the part of the brain that's particularly affected initially. And then the last part of the brain to evolve and also to wire is the cerebral cortex, and that's the thinking part of the brain where we have judgment and memory and learning. All that occurs in that part of the brain.
And that's right in the front.
That includes parts that we hear of, like prefrontal cortex, for example. Yeah, so that's just roughly.
I have a prefrontal cortex problem.
Yeah, and so where those mappings occur then, if you start interrupting the way the cells naturally communicate or healthily communicate, that's going to affect that particular area's function. So when somebody's intoxicated, you're suppressing cells in the cerebellum, which is why they will stagger, or in the speech area, which is why they will slur their words, or in memory, they will say things and hurtful things, but it's kind of like pulling lights out of a Christmas strand. If you pull them out all together, it shuts down the strand, and if you pull them just loosely, they kind of flickers. And so, yeah, it's
that's why people black out, you know, and don't have a memory of the things they did when they're under the influence.
Some that drink, right, correctly. There's now a scientific understanding that it's too much and the brain can't take that activity and slot it into long-term memory. So the person is there, they're saying really mean, horrible things to you, and then the next morning you're ready to go after the argument over what they said and did, and they're looking at you like, no, and so you can
well,
have
you know,
blackouts.
in Australia there was a pub with intellectuals who pontificated the most amazing ideas that they never remembered.
Oh, poor people.
I know.
Yeah. So when it comes to the teen brain, or the brain itself, if we look at the slide with early brain, we are born with roughly 100 billion brain cells.
Is that all?
And that's roughly what we have as adults. So think about it. If those were wired, if they were talking to one another and to and from other body parts through the nervous system, we would come out as infants doing what we do as adults. Obviously we don't. So in that first 3 years of life, that wiring starts to go together based on sound, sight, touch, and smell. What is happening in their sphere. Then it moves on to continuing, and we start to get it through books and through, you know, friends and online and sports, and that continues. And then there's this explosion, if you will, of neural networks, because you had to have a rough draft in order to be able to do all the things we can think, feel, say, and do.
So when you say a rough draft, what are you talking about?
Well, because it's so much that is out there. I mean, each synapse, every time we do something new, we are pushing synapses, or we're going along, you know.
This is like science fiction. It's like probes.
Yeah, right.
You know, is this planet Earth? Is this a humanoid? Is this a dog?
Right.
Is this fire? Is this water?
It's fascinating how this all goes together, because think about when we first start to ride a bike, for example. We're very wobbly and we're on training wheels, and then finally we're doing it. And then in the next, you know, whenever it clicks, we never have to remember how to ride a bike again. We just get on and we ride.
And that's because the neurotransmitters have clicked, brain maps have created the
memory.
Bicycle riding map.
Correct. Right?
Whoa.
So whatever then we're doing at that point, then the brain starts, if we'll go on to the next slide, of this explosive period of brain development, if you will.
What creates that explosion?
Here, we'll get to it.
Here's the mystery.
Here's the mystery.
This is probably the parenting mystery.
So this is a study that was done by Dr. Paul Thompson at UCLA, and this is a 10-year time lapse of how the brain develops, with darker colors being brain maturity. So around 12, we start to see the darker colors kick in, and then 16, it really starts to mature, and then 20, and now we know it goes until about 25. 22 is the average for women and 24 for men. And what starts at 12 is puberty. And puberty sets off 3 key things in the brain that were very important for us as a species to survive back in the day. And the 3 things are: take risk, turn to your peers, and then obviously to reproduce. Because if the species did not do that, we would not be here.
Okay.
So then it's not until around 16 that we start to get the cerebral cortex, the thinking, the wiring that allows us to break down problems that are complex and into doable parts. For example, we would never give our 12-year-old the keys to the car and say, go practice so you're good and ready by the time you're 16. We just instinctually knew that they weren't ready. There's a piece there that doesn't even start till 16, and that's the brakes on that risk-taking behavior. So that piece is starting, and then the 3rd key change is pruning and strengthening. So the brain says, whatever we're using, we're going to go ahead and strengthen that, and what we're not using, we're going to prune, if you will. Doesn't mean you die, doesn't die off, it's more just those synapses aren't being strengthened.
So can you give some examples of that? You know, are you saying that, oh, I really like the idea of studying and going to school, and I'm going to not sort of hang out with that crowd that distracts me from this? Is that what you mean by pruning?
It's how you process the input. So if say you're under a lot of stress, and then you get stuck in the limbic part, which is fight or flight, you will react to stress in that manner that you are starting to learn at that time, because that's where the wiring, and when I say by strengthening, it's what they myelinate, and it becomes wrapped in what they call myelin to make it a smoother, faster, more efficient transmission. So whatever you're using, the brain maps that as this is what we need, so we're going to strengthen this, and what we don't need, we're going to let that go by the wayside. So if you're substancing, that becomes, and what you know, how you get it, cover it up, use it, recover from it, all of those mappings will start to wire in, because that's where you're spending your time. If you're spending your time over here doing academics, and sometimes, you know, you're doing them in both places. And again, it's not that they die, it's more just a lost neural network opportunity. You don't know what might have been. But that's the beauty of the brain, is that it can heal. We can, when we stop or when we change our behaviors, And by that meaning, when we change how we think, when we get out of that limbic part of the brain, the reactionary part, and move into the cerebral cortex where we can think, which for a young person doesn't even start till around 16. And I don't mean that obviously they're doing incredible math and AP classes. It's not that kind of thinking. It's more of a take this complex based on all this and break it down into, if I do this today, that's going to affect me for the rest of my life. We don't have that yet. We don't have that basis of a decision making. And it's that lag time then from roughly 12 to 16 or 15 when teens will often get into trouble because they're instinctually, in fact, if we could go to the next slide, we'll see here briefly, just look at it, brain evolution. On the left, we have early man's brain, very small compared to today's brain on the right. And early man only lived about 25 years. That meant that when you went into puberty, when the species went into puberty at about 12, they had to turn to their peers, take risk, and reproduce, or we would not be here. And that's because mom and dad were dead.
Ooh.
So mom and dad are dead. If they didn't turn to each other and rely on each other and take the risk to get out of the cave or to let's go see what we can do in order to eat, we would not be here as a species. So that piece is still there. But then we tend to think that that means that they're adults, and because they have these adult-like bodies, they're not in the brain. And so we are frustrated, and why are you doing that? That was a bad decision, and what were you thinking? And they aren't, because that piece of the brain that can help them really think this through, whatever they're doing here, could affect me for the rest of my life, just isn't there. And it's also the brakes.
It hasn't evolved yet.
No, it hasn't developed yet.
Yeah.
And then that's also the brakes on that risk-taking behavior, so that part of the cerebral cortex development. So it's a bit of a complex, I hope it makes some sense, but yeah.
So it seems that between 12 and 15, 16, adults need to take more responsibility to create a virtual playpen in a way so that the risk-taking doesn't get dangerous.
Exactly.
And, keep substances, alcohol, drugs, marijuana out of the arena.
Right.
And then also, when the explosion, the brain explosion happens around 16, having some kind of role models of what good decision making is about. Not necessarily the good decision, but how to make decisions.
Correct. Yeah. Beyond just going through academics and making it that way, but taking in life, if you will. And the thing that's interesting about drugs and alcohol is they work on the brain's pleasure-reward pathway, which is in the limbic system, pleasure-reward. And that's what makes somebody even want to have a substance. Because let's face it, if it were as yippy as water, you don't have to think about drinking a glass of water for the same feeling of drinking a glass of beer. Right. And so it works on that pleasure-reward pathway, which is also where sex works. That works on that pleasure-reward pathway. And that's that part of the brain, the limbic part that's been with the species, that was designed to keep us here on Earth. And so helping kids understand this, the science of this, helps them appreciate, well, no wonder I'm attracted to him, I wish he would touch me, or those kinds of feelings, because that's just part of being human. We have these hormonal changes to make us want to have sex to reproduce. And that's working in the same part of the brain that the alcohol is working in, so you put the two together and you can just really have an unfortunate,
teen pregnancy goes up.
Exactly. So if we
that's
can
in
help
the heterosexual sense anyway.
So if we can help kids understand this better, they can appreciate that's a feeling, but I don't have to act on it. I don't have to. This is not compelling me, even though my brain's making it seem like it. I don't have to. In fact, it's better for me. So the idea is that alcohol and drugs, then, because this brain is developing, they work differently. They don't work the same way they do in an adult brain. And yet we tend to think, because we used to believe that the brain was developed around 12, that we had adult brains. And so we were going, well, of course, it's okay if they have a glass, or I drank and I was fine, and all those things we tell ourselves. And it just might not work in that particular child's brain. And let me just touch on that too. The 5 key risk factors for one person becoming an addict and another one just staying in substance abuse and eventually changing their drinking patterns or drug use patterns are childhood trauma. So anything that happens as that brain's going together changes the way that brain will interpret the world. Social environment. If you're raised in a family where there's heavy drinking or drug use is seen as normal, you'll drink or drug in that same pattern, and that might not work in your brain. Mental illness is another one, like ADHD or depression or anxiety or bipolar. All of those are brain changers. Right. And oftentimes somebody's substances, because it kicks that dopamine pathway and makes you feel better, to minimize the hurt of the emotional pain of the mental illness or whatever the outcome of that. So mental illness is another one. And then we have genetics. So we need to help children look in their family history. And it's not that there's an addiction gene yet identified, but it's higher or lower. Well, it'll be higher or lower levels of an enzyme or a neurotransmitter or the receptors. And so genetics, if it's in your family, you want to be especially careful. And then the last one is early use. And we tend not to start substance abuse education until middle school and high school, and yet it's all these brain changes that are happening from birth on that we can really help children understand early and parents understand early that, obviously, hundreds, millions of children or young adults will drink and come out the other end. It doesn't mean you're going to automatically become an addict or an alcoholic. But the other piece of this is that you could do something that could really, really hurt the rest of your life while you're drunk. You could also hurt somebody else. And that's a term, secondhand drinking. So if you are the best friend who's always anxious, worried about your friend who drinks every Friday and Saturday night, and you're trying to make sure she doesn't wander off with some guy or drive off with somebody, or if you're always the designated driver, you've got your friends in the car, they're drunk or they're high, and they're yelling, turn down the radio, I want you to, and you're trying to drive. That tension, that is a secondhand impact on you that, believe it or not, is triggering the fight or flight.
Yeah.
So that you start to freeze.
Yeah.
You start to then to react to that feeling as if it's a fact, and you got to do something. Okay, turn down the radio. Okay, and that could really, harm your coping skills. And so
you're driving.
And you're driving.
Yeah.
Yeah, so there's a secondhand, and it's the secondhand impact for your parents, worried about, oh my gosh, I found the pot and he says it's not his, and and all of that. So there's a secondhand impact of these drinking behaviors too. So
that's amazing.
Yeah.
So when you look at the brain development aspect of substance use, it makes so much more sense to keep substances away from young people if early use is a major impact.
It is. It is a key risk factor because it chemically and structurally changes the brain.
Right.
And that's always the beginning of a long-term problem. It's not, that you need that chemical and structural change, then that sets up that brain to be more susceptible to its risk factors.
Well, I have heard that for teenagers, when they start using earlier, 4 to 5 times more likely to become addicted, even to alcohol.
Because during that strengthening process,
Yeah.
that's what wires in.
Yeah.
That's where they're using their networks, is in that whole process, and so that will wire in.
And the same thing's happening with the marijuana of today, because it's much more potent.
Yes, yes.
Yeah.
Yeah.
Huh.
Yeah.
So what got you started in
All
this train of thinking and research and I can see you're excited about it too.
Yeah. Well, in 2003, one of my loved ones went into treatment for alcoholism, and that plunged me into this whole world of codependence, and it's a disease, and I'm like, oh, it's not a disease. Because I was bulimic, and I had learned to re-eat after 11 years of bulimia, so I always believed that addicts and alcoholics could learn to re-drink if they wanted to badly enough. So the first title of my first book in this area was If You Love Me, You'd Stop. And so as I set out to prove that this was not true, lo and behold, there's this whole body of research, and it is phenomenal what they're learning. And so it was scientifically understanding the brain disease of addiction, the brain changes in the family because of the chronic activation of the fight or flight stress response. And that was just compelling. And I thought, oh my gosh, we have to know this, and why don't we know this? So that was in 2003, and since I've written If You Love Me You'd Stop, and then Loved One in Treatment, Now What? And then an ebook, Crossing the Line from Alcohol Use to Abuse to Dependence. So I now take these, this research and message it for all different types of audiences. I just, you know, really, really, really want to try to get this out. And then my blog, of course, is another area where I write or have guest people write about these topics to just try to help us understand this is not a lack of willpower, because people who, no one, for example, sets out at 14 and says, I want to be a heroin addict. That's what I've always wanted. I want to be one of those. You don't.
No.
It's a progressive disease. And it wires in slowly or it wires in quickly, but the sooner we interrupt it, the better. And it's to just understand, yeah, you'll see friends who can drink and come out the other side. So this isn't about addiction necessarily. It's about giving your brain the best opportunity through this developmental process to be its best self, which makes you your best self, because the brain controls everything we think, feel, say, and do. And just the one last slide is to show that the brain can recover. So a lot of times we feel that, you know, that's it, a lifetime of this. But it does. This is on the left, you'll see the brain during substance abuse, and then on the right you see the brain a year later. Again, it's not to say that, and those are not holes, by the way, those are just areas of low blood flow, which is therefore low brain metabolism.
It's not a brain like Swiss cheese or anything. Yeah.
But the year later then is to also remind us, if somebody is in early recovery, that it will take a while, because you're putting this all back together.
Well, it's like rewiring.
It is. Mm-hmm.
Yeah.
Yeah. And so the key things to keep our brains healthy are nutrition, because neurotransmitters, for example, one of those keys in that neural network, are made of amino acids and vitamins and minerals. And so that's what you get out of nutritious foods. So if we can eat food in its most fresh, whole grain, non-processed product, the better it is for our brain health. And then exercise, amazing what it does in the brain. Sleep is another one, and unfortunately for adolescents, that's pretty tough to do, because they are under tremendous stress. I mean, when we went to school, an SAT test was, do you have the number 2 pencil?
I know. Well, thank you so much.
Oh, you're welcome.
We've been talking with Lisa Frederiksen from BreakingTheCycles.com, and we've been talking about the brain. Thank you. I'm Gabrielle Antolovich, your host with Voices United, in collaboration with the Pathways Society. Wow.